Let's look at how we can use the ping TCP application to validate connectivity to a device on the network. This application can use two different protocols to test connectivity. Ping uses the ICMP protocol. This is an effective way to ensure there's a valid network layer path between the test tool and the target device. The other supported protocol is TCP. TCP is useful when a device does not respond to ping requests or is desirable to validate a specific TCP port is open. Before running a test, it is necessary to configure the ping TCP application. I'll tap on the settings icon in the upper right corner to bring up the configuration screen. Device name is used to specify the target device. This may be an IP address or DNS name. In this case, I'll enter the IP address of the device I'd like to test. Next is the interface. The available interfaces will depend on the test tool you're using. In this case, I'm using an Etherscope NXG, so I have wired and wireless management ports and test ports available. I'll select any port. The application will use any of the ports that have a connection to the network and an IP address. The number of tests may be set to a specific number or continuous, which will run the test until you hit stop. As I mentioned previously, the application supports both ping and TCP. Ping will send ICMP Echos to the target and listen for replies. TCP will send TCP SYN frames to the target and listen for TCP ACKs. When ping is used, you have the option of setting the frame size and interval between pings. Setting this interval to 100 milliseconds is a great way to get a device to send frames if you're trying to locate it with the Wi-Fi tools. When using ping, you may also set the Do Not Fragment bit. This may be used with larger frame sizes to test the maximum transmission unit along the path. When I select TCP Connect, the port option appeared on the configuration screen. When using TCP Connect, we must specify the TCP port number on the target device. In this example, I'll set the port to 22 to ensure SSH is available on the server. The timeout threshold may be changed to one of the preset values or a custom value. Now that I've completed the test configuration, I'll tap the back arrow at the bottom of the screen and start the test. At the top of the screen, we can see the device name, the port used for the TCP Connect test, and the interface that's being used by the application. The number of requests sent and replies received are displayed, as well as the number of lost frames. Below is a graph showing the response times over time. This will allow you to see if there's a specific time when the target device is taking a long time to respond. The slider below the graph may be used to zoom in and out. Since I set the number of tests to continuous, I will hit stop to stop the test. The ping TCP Connect tool may also be accessed from the Tool Action button in the Discovery application.